Hello everyone. After a long time we meet here, and I just hope you to bring some videos or the video lessons throughout this period, as the schools are stopped here or the schools are temporarily closed. Then we can continue the lessons from this video mode. And the first fact. First, let's see what we have done so far. And the lessons, three units we did, and we know the method that we are doing these lessons. Usually, after finishing the discussion, normally we write answers for the questions. So we have written number of questions for all these three lessons. The final one also I just uploaded that one in the last session. I mean, uh, the third unit, all the questions or all the contents we discussed. Some students were absent on those days, but we discussed that in the class. I mean, in the school. So here, let's continue our lessons or the lessons from this mod. We are going to start unit number 4. Unit number 4, and the lesson will be done through this done by this mod. I mean, like a video. You can watch the video, and I will upload the video link to the WhatsApp. You are seeing that because you saw that through the WhatsApp, and also you can see the questions below this link. I mean, in the WhatsApp group. So you can open the PDF file and write the answers for the questions. Is it clear? So it is same as the lessons that we did in the school. There's no difference here. What you want to do is first watch the video, then write the answers for the questions. Then I will send or I will publish another video of the discussion of questions. Easy. There will be a theory video, then you have to do the questions, then there will be the question discussion. Nice. So always we will go through or the follow that method. Now this is our theory video or theory part, and then PDF will be uploaded later, or the questions, then the revision or the discussion we can have later. Right. Unit number 4 is about forces. What do you know about forces? 1 minute till I erase the whiteboard properly. So what do you know about forces? Basically, force is a kind of a push or a pull, right? Force is a push or a pull. In grade 7 we learned that for the first time. Therefore, anything which exert on an object to pull it or push it can be called as a force. Okay, then forces are measurable. We can measure the forces. To measure forces, we use force meters, and force meter is this one. This is a spring balance. So also we call this Newton's balance. Why do we call this Newton's balance? So there is a person who's respectable person, a great scientist, Sir Isaac Newton. Isaac Newton. He was the first one to reveal this type of concept to the world. There is a famous story, you know this story. When he was walking nearby a apple garden, he noticed that an apple fruit fallen from a tree. Apple fruit just fallen down from that. And he had a doubt. Why did the apple fell down? So when he think further, he came into one conclusion. And that conclusion is there is a force created by the ground which pulls that apple down. The apple fruit falls down because of kind of force created by the ground. Later he called this as gravity. He didn't stop the discovery or the exploration of the gravity from this point. He didn't stop it, I mean, right? He continuously experimented or explore more about the force. Finally, he found that forces can be applied in several ways. One thing, if there is something just pulling under the gravity, there is a force to it. Also, if the force is given horizontally, we can apply force. So look at this. The principle of the spring balance. If you see it closely, you can see on that one letter is printed. I don't know whether you can see it. Yes, there's N letter printed. That means it is newtons. So it is measured in newtons. When I pull it here, the spring stretches. Again, I will show it to close view. You can see the spring stretch here. Stretch in the spring. That means when a force is exerted on that, as the force increase in the spring stretch, then we can measure the force from this. That's why we call this force meter, the spring balance, Newton's balance. And how can we measure the force or the weight from this? Weight and the force. There is a relationship between the weight and the force. Weight is a force, right? Weight of an object is a force. Weight should be measured in newtons, because to respect that great scientist, we use newtons to measure the force, right? To respect the scientist Isaac Newton. So weight or force both measured in newtons. But some people think weight is measured by the kilograms. That is wrong. Kilograms are used to measure the mass. Mass is measured in grams or kilograms. So is there a relationship between the mass and the weight on this earth? When we stay on the earth, always the gravity pulls the things down. Therefore, there is a force to downwards, right? Gravity pulls the things down. Therefore, we can see a relationship between weight and the mass. Let's find weight is a force measured in newtons. Now I am going to show you the relationship between the mass and the weight. Okay, let's see this. This is a spring balance. This practical is given in your book, right? You can see the reading 0 now. Newton scale is this side. This side is the grams, 0 grams. Now I am hanging a weight. Here there is a weight set. I will take a weight set here. 1 minute. Okay. One weight is 50 grams, each 50 grams. So you can see it's 50 grams. If I turn the other side, you can see the Newton value. It's 0.5 newtons. Let's add one more. Now it would be 100 grams. 100 grams. See the weight. 1 newtons. This is the relationship. On our earth, 100 grams equal 1 newton. So if it is 200 grams, let's put 2 more weights here, 2 more, and hang this down. like this. Mass is 200, weight is 2 newtons. Then 200 grams equal to newtons. Guess one. Guess 1 kilogram. 1 kilogram. How many newtons? Guess it. How many newtons? It is, yes, 1 kilogram is 1000 grams. That is equal to 10 newtons. So easy pickings and easy conversions. Now let's talk what a force can do. Now you know we can measure the force in newtons, and also we can convert the mass into weight. So let's take, or let's check what a force can do. Push or a pull. Force can do things by means of motion and by the not means of motion. One thing, the things done by the force by means of motion, or things done by the force not by means of motion. Force can exert on objects to do these changes, right? Okay, let's see this. First one, by means of motion. What a force can do by means of motion. First thing, force can move an object. If it is not moving, move in an object. If object is still or the rested here, if you give a force, then it will move. First thing. Second thing, if this is moving now, if the ball is moving now, if you give further force, it will increase the motion, right? Or it can increase the speed up. Or if this is moving, if you give force to the other opposite side, then we can slow down the motion. Speed up, slow down. Next, if ball is moving here, if you give force to opposite side, I mean from the back side, if it is moving, if I give force to the opposite, we can change the direction. It comes here and changing and coming there. Can change the direction. So changing direction, we can change the direction. Finally, if object is moving, if you completely give big force here, you will be able to stop it. We can do 5 things on objects by means of the motion. Look at the 5 things. We can move a rested object. We can speed up a moving object. If object is moving, we can speed it up. We can slow down a moving object. Slow down a moving object. And we can change the direction of a moving object. Change in the direction of a moving object. Finally, we can stop a moving object. There are 5 things we can do by means of motion. You can see them in the textbook as well. Read the note in the textbook, right? That's how we do these lessons. Next, what a force can do by not means of motion. If a rubber band is pulling a rubber band, changing the shape, or we can stretch it. Force can stretch. Strong, no? Stretch things. Or if it is a lump of clay, and if you give force from top with your hand or something, just press it, it will change the shape. Change in the shape. Also, if it is a stick, and if you give force from this side, you will be able to break the stick into two pieces. Force can break things or shatter things out. They are not the means of the force, means of the motion. There is no motion take place in these instances, but when force is applied, these things can occur. Stretching things or bending things, right? Changing the shape of things and breaking things out. That's what we can do by means of motion or by applying forces on objects. Right. Now let's move on to this part. Forces can be measured horizontally or vertically. We can measure the forces. Do they have a direction? That's the next question. Do forces have a direction? Is there a particular direction to the forces? Right. It's very simple thing. If I want to give a force here to down, I should pull it down. But if I pull it cross, you can see force is coming to the other side. It was broken a bit. Okay. When I pull it from this side, it pulls this side. If I pull it this side, it goes that. I mean, always there is a direction to a force. There is a magnitude. That's why we can measure it by newtons. There is a magnitude and a particular or definite direction. There is a definite direction to the force. And when we give a force on an object, let's see this weight set. When we give force on an object, always there is a point that we apply the force, point of application, right? If this is the object, when I apply force from this side, it turns this. If I apply the same force from this side, it turns other side. Therefore, point of application is very important. Forces have a magnitude, it's a measurable quantity, also a definite direction, and always we talk about point of application, right? There are three things applied on that. The point where the force is exerted on an object is the point of application. Now, as we learned, forces have a magnitude or a size and they have a direction. If a quantity has a magnitude and direction both, we call such quantity as a vector quantity. Okay. If there is a magnitude and direction, if there are both, we call it as a vector quantity. So this vector quantity and is a quantity means there is a magnitude. What are the other quantities? If there is no particular direction, such quantities are scalar quantities. We are not going to learn about scalar quantities here, but I will tell you some examples. Mass, time, temperature, they have a magnitude but no definite direction. Therefore, they are scalar quantities. But force is a vector quantity. Again, I will highlight this. Just keep it thoroughly in your mind. There should be a direction. It should be a definite direction, right? If you just write that there is a direction, that is wrong. There should be a definite direction to become something a vector quantity, right? If there is just direction, that is not a vector quantity. That's also finished. Then next, these are the facts about the forces. Now, how can we represent forces? We call such diagrams as vector diagrams. representation of forces. Imagine this case. On this one, I exert a force here from this side. If the force is uh, 10 newtons, guess it, 10 newtons, and is moving that side. Or if we pull it this side by 5 newtons or 10 newtons, then it is the force. So there is a point of application and also a magnitude to the force. This is how we can represent it, right? We will draw the object. We should not draw it exactly with details. Just a kind of a demonstration or kind of model is enough. Proper square you can draw here, a square or a rectangle or something. Then mark the point of application. Then, as I mentioned, it was 10 newtons, but we don't write it here. We will represent 10 newtons by kind of tactic, using a tactical thing. Wait till I find a ruler. 1 minute, please. Right. Imagine this is a kind of big ruler. Then imagine this one section as 1 centimeter. And I can't draw whole 10 centimeter 10 here. Well, there are 10 parts, 1 2 3 4 5 likewise. This time I will I hope to take kind of a scale here. Look at the scale that I am taking. 1 centimeter equals 1 centimeter equals 2 newtons. That means if you want to represent that, you need only 5 centimeters. 5 times 2 is 10. So let's mark 5 centimeters here, right? 1 2 3 4 5. You must draw a line exactly 5 and draw an arrow here. There are 5. 1 2 3 4 5. 5 sections. 2 newtons, 4 newtons, 6 newtons, 8 newtons, 10 newtons. Clear? Then what are the importance, or that are the things denoted by these points? Let's keep the ruler. And now let's see the importances, or the things denoted by this. Right? This one is the point of application. I said that, point of application. And this length represent the magnitude or the size, magnitude of the force, the length of the line. This arrow is the direction of the force. Arrowhead is the direction. Right. This is a vector diagram. In vector diagrams, we don't mark anything. We take a scale and draw it like this. Actually, we don't label them. Just I label them to for the learning purpose. Let's try another one here. Let's try to read this type of vector diagram. If many forces acting on an object, if there are many forces acting on an object, right? This is the object. If there are many forces acting, as an example, here there are 3 sections and point is given here. Here there is only there are 2 sections here, 2 upwards, another 2 downwards. On same objects they are acting. So it says 1 centimeter equals, right, 1 centimeter equals 50 newtons. 3 points of application, 3 directions, and forces are x, y, z. Then see the magnitude of each. What is the magnitude of x force? 1 centimeter 50, there are 2 parts, therefore 100 newtons. This side also 2 parts, 100 newtons, 50 times 2. Here there are three parts. Therefore, how many newtons? It is 50 times 3, 150 newtons. But we don't write them. That is the special feature of these vector diagrams. And this is how we draw the vector diagrams. In my question list, I have included questions related to the vector diagrams as well. Now this is the whole lesson. It is a very small lesson. Actually, half an hour is more than enough to do this. And if you have forgotten some things, you can replay this and watch it again. Right? If you need to find the answers for the questions, you can replay and watch it and finally answer the questions. Question list. Right? Then again, I will make small summary here. Force is basically push or a pull, and force is a vector quantity because it has a magnitude and a definite direction. Force is measured in newtons to respect Sir Isaac Newton, and force is measured by the instrument called the spring balance or Newton's balance. And there is a relationship between the mass and the weight when it is applied on the earth. Right? Weight is the gravitational pull on a certain mass. Gravity pulls it down. Therefore, there is a relationship between that two. And 100 grams on earth is equal to 1 newton. 200 grams 2 newtons, 300 grams 3 newtons. Likewise, we can easily convert it, but it's valid only on the earth. Remember it. If you go to the moon, imagine if you go to the moon, that conversion is not correct, incorrect, because on moon gravity is different. Right. Then that is the summary of today's lesson, and you can give comments, but I don't ask you to put always don't put thank you or don't say thank you on the group. If you have a doubtful thing, you can ask in the group. Then don't make the WhatsApp group a kind of mess by saying thank you to each and everything. So use it fruitfully and in decent manner, because that WhatsApp group is not mine, it's yours. Then you have to use it in decent manner. That is one of my requests. And my next video will be about the question discussion. It will take about 5 or 10 minutes, right, for the discussion of questions. And we will meet after 4 or 5 days later to discuss the questions. And the next lesson, unit number 5, it's about pressure, will be started, or will be done on next week. After 1 week later, we can do the lesson number 5. And share this message to everyone, share the video to everyone. And because if they don't have have facilities to watch this video, ask them to watch it somehow, and just what we call just make them enthusiastic, right? Okay, it's half an hour for the whole lesson. And goodbye everybody. Let's meet back from the question discussion.